Okay, how's it going, everybody? So today we're going to be talking about area of a trapezoid. And as we have learned over the last couple of lessons, that so far all area has been based off of the general shape of a rectangle. And so we're going to take a look at this shape and see if we can't manipulate it in some way so that it also can be used the general form or general equation of a rectangle, which is area equals base times height. So trapezoid is denoted or identified because we have at least one pair of parallel lines. So since I have one pair of parallel lines, these lines don't matter if they're not parallel. This is still considered a trapezoid. So what we're going to do here is we're going to make some markings on the trapezoid. I'm going to go ahead and highlight the top, and we're going to call that B1. And then I'm going to highlight the bottom, and we're going to, right there, and we're going to call that B2. And so what we don't have notated in this, because there are no dimensions or numbers or anything, is the height. And if we're going to be using the area formula, which is area equals base times height, I would have to have a height. And one thing we do know about the height is at a right angle with the base. So if I look at this angle here, I know for sure as I'm looking at it that is not a right angle, nor is that a right angle. So I'd have to be giving the notation of the height. And so again, normally what it would be is some sort of dashed line kind of in the middle like that with the right angle. It'd have to be given that height in order for this to us to find the area of this trapezoid, excuse me. Okay, so there we go. That's what we have so far. So what we're going to do next then is we're going to cut this trapezoid in half. All right, so I cut it right along the height, half of the height, so that I cut the height in half. So I now have two trapezoids. I have a small trapezoid, which is right here, with the green base on the top and the purple base on the bottom. And then I have the larger trapezoid, which is this one on the bottom, that looks like that. So I'm going to go ahead and highlight that larger one a little bit and see if I can't make it a little clearer for us. I'm going to go a little more opaque here. Okay, so this is my bottom trapezoid right there. I think you probably can see that. And then I'm going to this now has been cut in half. That line there, as has this line over here been cut in half. So what I'm going to do is I'm going to take this trapezoid on top here, and I'm going to rotate it and flip it so that it fits right next to this other trapezoid that I have already on the bottom. So I'm going to take this green part here, flip it over to the bottom so the green is going to be down there. So I take this and I flip it around. So this line here is going to be flipped down to the bottom here. So this is now my B1. It's the same as this line right here. Now, this purple line from this small trapezoid, if I flip this over to the bottom, then that purple line would extend out like that. So that's going to be my purple line. I extend it out. It keeps going out like this. And this line right here is the same as this line right here. So this line here is the same as this line here, which means This blue line right here, if this has been flipped around, is connected to this one, and this blue line comes all the way over and would connect right there. So I'm going to go ahead and draw that blue line in. So now what I have is a new trapezoid, a parallelogram. And the parallelogram is denoted by this area, or this shape right here. Whoops, I'm going to do this in highlighter. So there is my new parallelogram. It is denoted by the trapezoid on top, which is right here, that has been flipped over and is now right here. So I'm going to clean up some of my colors here so you can see that this is my B1 right here. That's this side right over here. And then this right here is right there. And this side right here is that side, is that side right there. So my new trapezoid looks like this. My new parallelogram looks like this. And it's broken up into some parts to where this right here is B2, this right here is B1. So that means the distance from here all the way over to here would be B2 plus B1. So that distance is B2 plus B1. To go all the way from here to here is the base 2 plus my base 1. So that's part of what I need for the area formula. And then the other part I need is the height. Well, if we think about what we did up here at the top, we took the height and we cut it directly in half. Remember, that was the very first thing I did, is I cut this trapezoid in half. So I took my height, whatever my height was, and I cut it in half, which means if this trapezoid right here is this trapezoid right here, then if this was my original height, then this is going to be half of that height. So the new height of my parallelogram is half the original height of my of my original trapezoid. So the formula I can write is this: area equals base times height. That's the area of a rectangle, which is also the formula for area of a parallelogram. The base is going to be B1 plus B2. The height is going to be half of the height, so h divided by 2. So whatever my original height of this original parallelogram, whatever the original height was, I cut that height in half. And so that's why it's height divided by 2. So a lot of times what you see for this formula is this: area equals 1/2 B1 plus B2 times h. So this is a very typical formula for the area of a trapezoid. Area equals 1/2 the B1 plus B2 times the height. or 1/2 height times b1 plus b2. Okay, let's take a look at it and see what it looks like in motion. Okay, so here we go. We have a trapezoid. And so you'll see that I put the notations in a couple of different places because I want us to get used to it. What I'm looking for here is the right angle. I don't care if they put the notations on the inside or if they put the notation on the outside. The only thing that I care about is where is this right angle. So when I see that, I now know what my base and my height are, and more importantly, I know which numbers I don't need. And the numbers I don't need are these slant numbers. So I don't need the 13, and I don't need that 13, because the 13s have nothing to do with this base and this height, which make my right angle. Okay, so now I know then that this must be B1 and this is B2, or the other way around. It doesn't matter which one is B1 and B2. And then over here must be my height. So that must be the height there. So the formula I use for the trapezoid is area equals 1/2 h times b1 plus b2. And a minute ago I had 1/2 times b1 plus 2 times h. The order doesn't really matter. Makes a little more sense to have the h first, but not that big a deal. So then I have 1/2, and my height is 8, and my base 1 is 4. That's this one here. And my base 2, whoops, that should be a plus, is 20. So then 1/2 times 8, that simplifies out, and I get 4 times 4 plus 20 is 24, which equals 96. So the area is equal to 96 square units. Okay, so that's how you do it. So I use that formula of area equals 1/2 h times b1 plus b2. And then I make sure that I know where my right angle is. My right angle is right there. Therefore, that's my height and that's my base. And so this is my base 1 and this is my base 2 because these are the lines that are connecting the height. And what I didn't need were the 13s. Okay, let's take a look at another one here. Okay, so we look at this one, this trapezoid, and it has a set of parallel lines, but it's oriented a little bit differently. And the other thing that's different about it is that it gives us the right angle here. So the two of the lines that are in my trapezoid make my right angle, where in the last slide they weren't part of it. So they had to do the dashed line. So this is a little bit different, and it's oriented different. And I did this on purpose, of course, so I want us to see what this would look like. Well, the first thing that we would do if we were gonna actually have a piece of paper that we could cut up is we would need to cut the height in half. So looking at this, if I tried to cut it like this, well, which of these two is my height? They're both touching this base with the right angle and the right angle. So I don't know, am I cutting the 10 in half or am I cutting the 6 in half? So that's not how I cut it. Actually, I'm going to cut it like this. So that's how I'm going to cut this one, is that way. So I'm going to go ahead and do that. So I cut it just like that. And now, here are my two trapezoids. I've got this big trapezoid on this side and the smaller trapezoid on that side. So the number that I don't need, because the number that's not connected to my right angles at all, is the 45. So that's the number that I can cross out. So now I go and I use my area formula, which is area equals 1/2 h times b1 plus b2. And then I have 1/2 times, and my h in this case is right there, 30. And then my B1 is right here. It doesn't matter which one is B1 and B2. It doesn't matter. They're getting added together. So 10 plus, and then the other one is 6. And then I go to solve this, and the 2 goes into 30 15 times, and, oops, excuse me, 16, not, I almost wrote 10 plus 6, and that's, so now 15 times 16 is equal to 150 and 75, 225. No, that can't be right. 150 plus 80, not 75, would give me 230. So 230 units. Okay, so that's another looking trapezoid shape, but it's done basically the same way. The key thing is, again, to identify the right angles. You get those right angles identified, that gives you the bases and the height, and then you can plug it into your same equation. And remember, this equation was based off a rectangle. Okay, that's it.